So once again, H, we said, is my horizontal shift, my translation left or right. If it's inside the parentheses, I got to think opposite, right? So if there's a -4, that means I'm going to the right. If there's a +4, I'm going to the left. My K hanging off on the end, that's my vertical shift, up or down. No opposites here. +2 means I'm shifting up. -2 means I'm shifting down. All right? Now this letter A here, this coefficient, is my dilation constant, also called, hopefully we've heard this term before, a scale factor. So when I was translating my functions, I wasn't changing the slope or the angle of my line. I was just taking my line and shifting it up, down, left, right. But if I dilate something, I'm making it bigger or smaller, I'm changing the size of my line's slope. Okay? What are these little guys wrapped around this A right here? What do we call that?
Absolute value.
Absolute value. So if the absolute value of A is greater than 1, what that tells me is that I am stretching my function vertically. Stretching my function vertically. Good morning, Avery.
Hi.
Thank you.
Hi, friend.
Oh, this is after school. I was about to say. Stretching vertically. So if I stretch something, right? If I stretch something out, I'm making my slope a lot bigger, which is making my line steeper. Okay, we'll get a visual for this in just a second. If the absolute value of my coefficient A is less than 1, if it's 1/2, if it's 1/3, if it's 2/5, right? A fraction less than 1, I'm going to be compressing my function vertically. Do you guys know what chest compressions are? Yeah?
Speaking of. Oh, really?
What's another word, or I guess an abbreviation for chest compressions? 3 letters. Isaac, what is it? CP and R. That's right. CP and R. Okay, what do you do when you're administering CPR if part of that is chest compressions? What are you doing? Yeah, Alex?
Wait, you're trying to get someone to hear?
Yeah, what is it? What does the motion look like of doing chest compressions? You guys have seen it in shows, right? Put your hands on the chest and you push down. If I'm compressing your chest, I'm pushing it in, right? Take a look at this little guy right here, okay? This is Mr. Egg, all right? He's going to help us learn about dilating linear functions, okay? If I were to stretch Mr. Egg, right? I'm going to take the top and the bottom, and I'm going to pull and stretch him like this. You guys see that? I'm stretching him out. The slope is going to get a lot steeper. Now, let's let him get back to normal here for a second. If I was going to compress Mr. Egg, that means I'm going to flatten him. I'm going to make him nice and compressed, nice and flat. You see that? And now he's uncompressing. But if I were to compress Mr. Egg as hard as I can, okay, that's what he's going to look like. Do you guys see the difference between compressing and stretching?
Yes.
Okay. If I were to stretch him out, oh, I might rip him.
Oh no.
That's okay. He was free. So if I'm stretching, that means I'm taking my function and I'm stretching it out. I'm making my slope steeper and steeper and steeper by stretching it. If I'm compressing it, that means I'm making my line flatter and flatter and flatter, which makes my slope smaller and smaller. Okay? Now, there's a reason why A is in absolute values, okay? Because negative A is a completely different thing. It's a different transformation entirely. If my a is negative, if I see a coefficient out in front that is negative, what that means is that I'm reflecting across the x-axis, along with potentially a stretch or compression. Okay? A reflection, again, looks like this. If I hold my hands out like that, right? A reflection is just a mirror image. Okay? A translation looks like this. I take my hand and I slide it over to this position. But if I'm reflecting my hand, that means I'm flipping it across a line of reflection, which I think we've already talked about, right? Lines of reflection? Yeah. So let's take a look at some g of x's. My parent function here, abbreviation for function fxn, is f of x equals x, right? That's my typical starting point, my parent function. Let's say I do something to it to where I get g of x, which is equal to 2 times x, all right? What is my a value here equal to? 2, right? What is the absolute value of 2? 2. So, is my a value bigger than 1 or less than 1? Bigger. That tells me that the transformation I'm doing here is a vertical stretch. Remember, Mr. Egg getting taller and taller. I'm stretching him out. Vertical stretch of, or by a scale factor of, but I'm not writing all that. Vertical stretch of 2. That's the transformation I can identify based on this. G of x is equal to 2 times x. Now you're not always going to see the parentheses. Sometimes you'll see it written like this. G of x equals 2x. Same thing, right? It's not being added or subtracted, so it can't be an h or a k value. That means it must be an a value, all right? Let's go back to Desmos and see what this looks like for a second so that we can visualize once again. This is a lot of visual stuff here. If I have f of x is equal to x, right? There's my parent function in red. And I were to stretch it by a scale factor of 2, what do you notice about my blue line when you compare it to the red line? Steeper. Got a lot steeper, right? What if I up that 2 to a 5? What happened now? It got more steeper. What about 10? It got more steeper. What about 100? Super duper steep. Almost vertical. Not quite, but almost vertical. So the bigger my A gets, the steeper my line becomes. But what if I have 1/2? What happened to my blue line now? Is it steeper than my red line? No, it's flatter. Flatter, hey Mr. Barth, flatter than my red line. What if I did 1/5? It got even flatter. What about 1/10? Even flatter. What about 1/100 or 1100? Super duper flat, almost horizontal, but not quite. So as we can see, if I have a fraction in front, I'm getting flatter. I'm compressing Mr. Egg. If I have a whole number in front, a non-fraction, a whole number, or anything greater than 1, I want to be careful. Because if I have 3/2, that's still greater than 1. I'm stretching it. I'm getting a lot steeper of a slope. Okay? But what if I have a negative in front? What happens to my blue line there? It reflected it over the x-axis. We'll talk about that in a second, but I just wanted you to see that. So g of x now, let's say is equal to 1/3 x. What's my a value here?
1/3.
1/3. What's the absolute value of 1/3? 1/3. Is that more than 1 or less than 1? Less than 1. So this is a vertical what? Compression of, what's my scale factor? 1/3. That's it. Pretty easy, right? Good. Third example. What's my a value here? Negative 3. Ooh, a negative number. Does that mean I'm compressing it, squishing it down?
The absolute value.
What's the absolute value of negative 3? 3. Is that more than 1 or less than 1? More. So this is a vertical stretch just because it's negative. That's why I have to think in terms of absolute value. Because if my A value's absolute value is greater than 1, I'm still stretching it. Vertical stretch of 3. However, that's not all I'm doing here. And I'm also should I say reflecting or reflection? Vertical stretch of 3 and reflection across the x-axis. So I'm not always just going to be doing one transformation. Sometimes I've got a laundry list of transformations that I'm applying to one specific function. Okay? So I really want us to make sure we're understanding. The negative sign is its own transformation. It's its very own thing. It's a reflection across the x. When I'm figuring out, am I stretching or am I compressing, we're only looking at the number itself, not the negative sign. So what about this one? G of x is equal to 3 over 2x. What's my A value here? 3 over 2. All right, that's definitely an A value, my scale factor. Am I stretching here or compressing?
Stretching.
Am I stretching or compressing? Stretching. Why do you say stretching? Because it's more than 1. Don't be fooled by the fraction. If it's more than 1, it's a vertical stretch. This case of 1.5 or 3 over 2. Everybody cool on that so far?
Yeah.
Okay, let's kick it up like 10 notches. Look at this last example here. There's a lot going on. There's a lot going on. Let's start left to right. What's the very first thing we notice in G of x? What's that? Distribute. We're not doing math. We're just identifying what's going on. What I see a negative. That's the first thing I see. What does that negative A value tell me I'm doing here? Reflecting. So the first thing I'm doing is reflecting across, so always the x-axis, bless you. Because if I have a slope of 1 and a slope of -1, that's the same sloping line just being reflected. If you can imagine like reflecting it over. All right? What do you see right after that negative sign? 1/2. That's my A value, right? Is that bigger than 1 or less than 1? Less than 1. So what does that 1/2 tell me I'm doing here? Compressing. Want to be specific? Vertical compression. If you look in the book, it does talk about horizontal stretching and horizontal compressing. We're not going to worry about all that. We're just going to focus on vertical. Vertical compression of, what's my scale factor? 1/2. Is that all I'm doing? No. What's the next thing I see in there inside the parentheses? I see a -4. That -4 tells me that I'm translating, someone said it, translating
To the right.
to the right, exactly, because the minus sign in the parentheses tells me I'm translating right. How many units to the right? 4 units. Am I done now?
No.
No, I got one more. I got that +2 on the back. What letter or what variable is that +2 representing? That's my K. So my K tells me that I'm now translating once again. This time, what direction am I translating? Up. You sure we're not going down? All right. Thank you. Translating. Up. How many units?
2 up.
2 units. How do we feel about that one? Just break it down, piece by piece by piece. Go left to right. Write down each of the things that you see happening. That's as complicated as it's going to get. Is that guy right there. Okay? Feeling all right?